Good morning. Good morning, all of you. Hope you had a great evening yesterday, and if this is your first session today morning, then welcome to day 3 of Cloud Next. I'm sure by now you would have seen various different, very interesting AI, ML, and analytics demos and innovations which Google Cloud is bringing to the market. In fact, if you haven't seen the Wendy's drive-in at the Expo Hall, I really encourage you to go and try that. It's really interesting. And I'm sure many of you want to go and try out some of these projects, get it started in an organization. But, and there's always a but, for any of these projects to really happen, the first step is moving terabytes or maybe petabytes of data to Google Cloud. And if you're wondering if this data transfer at scale is easy, the answer is yes, and this is the session we are going to show you how. My name is Banjul Sahai. I'm one of the lead product managers for Google Cloud Storage. I'm joined by my colleague Ajitesh, who is a product manager for transfer service, joined by Guilherme Bedin from Globo, one of our marquee esteemed customers, and Guilherme Silveira from our partner Thoughtworks. And together, we're essentially going to cover 3 things. Number 1, give you an overview of Google Cloud data transfer portfolio and how it makes transfer really easy. Second, we'll talk about best practices for moving data from on-prem to cloud, as well as for setting up multi-cloud data pipeline. And finally, we'll hear the real-world story of Globo and how Thoughtworks helped them migrate to Google Cloud. And it's a very interesting one, and hopefully it brings together what we talked in the earlier parts of the presentation. Great. So before we get started, I just want to recapture that data transfer tools, what we talk about today, is a part of our storage portfolio. And storage, computing, networking, all of these together form our workload-optimized infrastructure offering from Google Cloud. And once again, these services are built to help you run your AI ML workloads for sure, as well as modern container workloads, and are equally well set to run your existing workloads like SAP, VMware, and all that. So let me start it with the first section to give an overview of the data transfer portfolio. Now, there are multiple use cases and scenarios for data transfer. So there are customers who move data from on-prem to cloud, and they may run their own custom analytics tool on GKE, GCE, and there are other customers who are closing data centers and moving their workloads to Google Cloud. Both of these cases, data transfer is a problem to be solved for. There are many other customers who are moving data across cloud, and they're setting up multi-cloud data pipeline. And you will see some very interesting data points on this, maybe just another 2 slides down the presentation. Again, they want to take advantage of Google Cloud's industry-leading analytics products. And then there are, of course, customers who are moving applications from other cloud to Google Cloud. There's also the third scenario, which is customers, once they have their data in Google Cloud Storage, file store, they want to manage that data better. And this could be for DR reason, backup reason, or archival. And the tools we will cover today, or the services we talk about today, also help you cater for this third category. But in the presentation, we are going to focus on the first 2 scenarios and share more on that. Now, data transfer at scale is not easy. If any of you have done this before, you know that performance is a big concern. How do you make sure that you use the whole of network connection and don't use so much that you cause problem for your running application? You want to make sure your compute and network is optimized. You, of course, have to, or many times customers end up writing scripts which they have to manage, upgrade, all of that. And how do you make sure that data is securely transferred? Make sure that the integrity is there and validate it. You don't want to delete your data from the source and then you find out there are some issues on your target site. So all this is tough. And the other one, which is not there, but is always a big elephant in the room, cost. how do you do this transfer at the right cost and not end up where the transfer itself is 20, 30% of your overall product and leads to big questions on ROI. So moving data at scale is complex. The good news is the Google Cloud product portfolio in data transfer is pretty robust and simple and helps you solve for that. So first, we have transfer appliance. I was in a customer conversation just yesterday. They're using these appliances very well. They move data from their regulated environments, on-prem scenarios, to Google Cloud using the appliance. There's another very interesting variant of transfer appliance if you're not aware. So if you have data getting generated in Edge, like we have a customer who are using these appliances with rovers, you can have the data come to appliance in an offline scenario, and then whenever the appliance is put in a connected environment, it will move data to Google Cloud. So there's this hybrid offline-online approach also available with appliance. We have G-Cloud storage tools, which we recommend for small data transfers for both on-prem to cloud or within Google Cloud. And then our most popular tool, most commonly used by customers, is storage transfer service, which essentially caters to all the three scenarios, which is on-prem to cloud, within GCP, and across different cloud. So this is simple three-product portfolio, but very robust, been around for a couple of years to cater to these requirements. Now, I believe, and we think that these products really make it easy, but nothing better than that. Rather than taking my word, why not hear what customers have said about this? So today is the first time we are sharing this publicly that we have thousands of customers, multiple thousands. I don't mean 1,001 only. Thousands of customers who are moving data every month from AWS and Azure to Google Cloud, and most commonly they use it for running analytics workloads on Google Cloud. Thousands of customers, and we have had this pattern. So these customers have some of these workloads running on other cloud. They have set up this regular monthly data pipeline, and then they use BigQuery, Vertex AI, Dataproc, these tools, these services on Google Cloud. So if any of you have been considering this kind of a multi-cloud scenario, absolutely feel confident that there are many other customers who do it today, and they've been doing it very successfully at scale. Now, if we talk about on-prem to cloud, again, one of our esteemed customers, Tim Brazil, they moved petabyte scale of data, found it very easy, seamless, saturating at 20 Gbps connection. So again, some proof points to share with you that these tools have made customers' life easy, help them do this transfer at scale in a seamless way. Now, let me talk about storage transfer service. As I shared, this is one of our most popular tools used most commonly by customers. So quite a comprehensive set of features. The service has around been a couple of years. So security, performance, managed features, controls, we have built on all of these different aspects. The two of them which I'll highlight, starting with the first one, is over the last 12 to 24 months, we have done a significant amount of work to really improve performance, to improve the performance of transfer, especially for small and large files. So, I would say that the performance which you would get from storage transfer service is significantly better than some of the other competitive options there. The other one, which is a recent release, is event-driven transfer. So you could have data coming in and using pub/sub notifications or real-time event, have that data transferred across cloud to Google Cloud or within Google Cloud for processing in Google Cloud storage. So it's a very interesting feature. With this, you could start taking use of Vertex AI and some of their real-time analytics services, even if your data is not exactly in the same location. So if you haven't, something worth checking out if it fits your use case. And here's a quick recapture of some of the recent features and releases of storage transfer service, as well as our other transfer products, what we have done. I'm not going to go through each of them, but maybe highlight two of them. The first one is a new support for any S3 compatible object storage. So there are customers who may have an S3 compatible object storage in their on-premise environments, and now you can use that to transfer data to Google Cloud Storage. Or even if you have data in S3 or some of these other cloud object storage offerings, this gives you a way to shape the network pipe, the network connectivity and data transfer to get better costs or performance in some scenarios. So it's a very interesting feature, helps with that. We're also about to launch HDFS support. So for customers who are running on-prem HDFS environments and they're looking for a way to move that to Google Cloud, we are going to support that with storage transfer service. Again, the performance of this in our tests we have found is significantly better than some of the other tools which are available today. This is a service which runs outside of the cluster. So if you're trying to vacate the cluster, you don't have to consume those resources and you can get significantly better performance. So once again, my section, what I wanted to leave away is we have a pretty robust set of tools, services which can help you make the data transfer easy at scale. And again, hopefully you noted some of these customer testimonials to prove they have been doing that pretty regularly. I'll now invite Ajitesh to come and give us some best practices details for both on-prem to cloud and then multi-cloud transfers. Ajitesh.
Thank you, Manjul. So I'll walk you through the best practices for on-prem to cloud and multi-cloud data transfer. So starting with the first one. So when it comes to data transfer, there are three critical parts. The first part is figuring out the planning, that what data sets you'll move and who will do the data transfer. One thing to note here, that legal and security play a pivotal role. They approve the software that you need to deploy, the hardware that we'll be using, and what data sets move to cloud. So make sure you engage with all the stakeholders early in the cycle. The second step is figuring out how to do the actual transfer. And this has two parts. The first is what transfer tool will you use? For example, if you're operating out of a data center where there is low connectivity and the cost of setting up link is really high, you should use data transfer appliance. In the case when you have good connectivity or want to land data as quickly as possible, use storage transfer service. The second part of this is what migration approach should I use? To a large extent, this depends on how much downtime the application which is using the storage can take. One of the popular approach is highlighted in the bullet 2 here. This is a two-step transfer where you do the seed transfer, that is bulk copy the data from source to destination. And during this time, you keep reading and writing from the source. Then you take a downtime at the source and do a sync transfer where you capture the delta all changes from the source to destination. This is popular because it results in minimal downtime and also requires less engineering effort. Once you finalize the approach, then you do the actual transfer and then move to third step, which is validating transfer. There are two approaches to validate transfer. First is to match aggregate statistics, that is total number of bytes copied, total objects copied. Or you can go object by object and compare size and MD5. We offer you a couple of options to make it easy for you. So that's the high-level approach. Next, let me cover specific best practices when using STS to move data from on-prem to cloud. So on the right-hand side here is the high-level architecture. So we ask you to download STS agents, which are a Dockerized application. These agents run on a VM close to the source. And when you create the data transfer job, these agents work in parallel to read data from the source and write to the cloud storage bucket. Jumping to the best practices, in the planning stage, we recommend doing quick and early POC. In doing the POC, make sure you are testing with 1 to 5 terabytes of data. That's critical because if you are using less data, it will not give you the right picture. STS is designed to operate at terabytes and petabyte scale. One other thing that we recommend is don't directly write to colder storage class. If you have to take any corrective action, this will result in high API ops and early delete charges. The next one is pertaining to performance. If you want to scale performance, just add more STS agents. If adding agents does not lead to higher performance, that means there are bottlenecks in other part of the system. One of the things that we see commonly is that in the older storage system, you have lower read throughput limits. So make sure you are using tools such as FIO to measure the read limits. STS provides a lot of rich controls, so make sure you're using the right one. For example, we often see that the data transfer workload and the operational workload uses the same network pipe to read and write from the cloud storage. In that case, you don't want transfer to consume the entire bandwidth. In that case, you can use STS bandwidth control to monitor and control the STS bandwidth that STS consumes. And finally, make sure you are validating the transfer. We already spoke about a couple of ways you can do that. So that's on the best practices for on-prem to cloud side. Next, let me cover specific best practices for setting up multi-cloud data pipeline. So when we speak to customer about this, there are three major considerations. The first and the top one is the egress cost. Egress typically account for 90 to 99% of the transfer cost. And there are multiple ways to egress data from other cloud. I'll be covering specific details in the later slides. The second major consideration is performance, and this has two dimensions. The first one is throughput. If you want to scale throughput, just add more STS transfer job. A single STS job copies 1,000 objects per second and scales up to 10,000. If you trigger 10 jobs on parallel prefix, you can right away get 10,000 object copies per second. The second dimension here is latency. For a lot of workload like predictive analytics or low RPO backup, you want to land data as quickly as possible. In this case, you can use STS event-driven transfer. Here, we'll listen to change notification at the source and copy the data in near real time. The third factor is security and reliability. To a large extent, STS takes care of this out of the box. We encrypt the data in transit, do automatic retries, check some matching. But you can take certain steps to make it more secure and reliable. For example, when giving STS access to AWS resources, make sure you are using STS federated identity. In this case, STS assumes a role in AWS environment and generates short-lived tokens dynamically. These are much more secure than using long-lived credentials. When it comes to reliability, one thing we recommend is to use cloud logging and cloud monitoring. With cloud monitoring, you can get notified when the performance metrics are down, and then you can use cloud logging to dig deeper to understand why that happened. We offer multiple options for you to egress data from AWS S3. The simplest and the easiest one is to use STS and BigQuery data transfer service, though they do result in higher egress charge. Another option is to use BigQuery Omni data transfer. This is suitable if you are using BigQuery Omni and want to land data to BQ. The other two options highlighted here in the blue box result in 60% lower egress charge. I'll be covering these options, namely egress via private network and egress via Cloudfront in the next two slides. So how do you egress data from private network? So there are three easy steps. The first step is that you create this cross-cloud infrastructure. You can use either cross-cloud interconnect, which is a GCP offering to do that, or you can use third-party vendor like Megaport and Equinix to create this. Once your network is set up, you go to the GCP side and deploy STS S3 compatible agent on a GCE or GKE node. When deploying on the GKE GCE node, make sure these node can speak to S3 VPC endpoint. Once this step is done, you go to STS console and create a transfer job that can speak to S3 VPC endpoint. Now your transfer will happen via this private network and result in 60% lower egress charge. Couple of things to note on this slide. This requires deploying you this fixed infrastructure, which result in certain cost. And that's why it's more suitable if you are moving 100 terabytes plus data. Second, when we interact with multiple customers, they also have these top-down mandates to not use public internet. In that case, this offers a viable path and also much more predictable performance. There is one more approach to egress data, that is via Cloudfront. So this is how you set this up. The step one is you create a Cloudfront distribution for your S3 bucket. You can do that going to AWS console, clicking few buttons. Then you come to STS page and create a transfer job supplying this new Cloudfront domain. Now your all transfer will happen in two steps. First, it will go from S3 to Cloudfront, the loading which is free. And second, that will egress from the Cloudfront, which is substantially cheaper. Couple of things to highlight about this approach. This feature is currently in the control GA phase. So if you want to get access to this, reach out to the account team. They can get you enrolled. Second, this does not require paying for any fixed infrastructure. So it's suitable even for a small amount of data. So megabyte, terabytes will also do. So that's on the best practices side. Next, I'll invite on stage our marquee customer, Globo, and our Google Cloud's premier partner, Thoughtworks, to walk you through the successful migration story of Globo. I'm really excited to hear that. Thank you so much, everyone.
So my name is Guilherme Bedin. I'm from Globo. I manage the big data platform teams there. And Globo is the largest media company in Latin America. Globo has broadcast channels, pay TV channels, and digital products for news, entertainment, and sports. Globo has more than 100 million users per month. And Globo Play, that's our streaming service, has more than 30 million paid and free users in our platform. In 2018, Globo starts its digital transformation, paving the way to become a media tech company. And Thoughtworks was one of the key partners helping us in this journey.
Hi, my name is Guilherme Silveira. I'm a technical principal at Thoughtworks. Thoughtworks is a leading global consultancy that integrates strategy, consulting, software engineering, and design. We collaborated with Globo on this project. This project is a sub-part of a larger digital transformation of Globo, and Thoughtworks is also a premier partner of Google Cloud.
In 2022, Globo migrated its on-premise workloads to GCP. And these workloads are from delivering all the content for our digital products, big data pipelines, and back-office tools. In this presentation, I will talk about how we migrated the Globo Play big data pipelines to GCP. So before GCP, this was Globo Play big data high-level architecture. We have a data ingestion system that captures user behavior from all global digital products. They collect things like page views, video views, clicks, and everything that the users interact with the products. In that time, we use Nginx, Go on Kubernetes, and Spark streaming on Hadoop to store all this data. And Globo Play processes all this data with PySpark and Hadoop to understand how the user is behaving in the product. So they can do user engagement and performance of the content. But this solution has one problem. It's auto-scaling, because we need to predict the highest peak of the year and providing all the resources that we need in the data center for it. And this approach leaves a lot of idle resources during the year.
So after migrating all the data, we collaborated with Globo to modernize a data pipeline from the older proprietary solution to a solution 100% based on GCP. Before we get into the technical details, it's important to contextualize everyone about what business problems are we solving, and how this data will be used, and what value we're bringing to the business. So Globo Play is a streaming app. It generates a lot of data from the user's interaction using the app. This data, we go into two different domains. The first domain is the marketing domain, where we are answering questions such as, what's the performance of our marketing campaigns? How can we engage users more? How can we reduce users' churn, and so on. The second domain is the intelligence domain. We answer questions such as, how can I have a 360 view of our users across all digital products of Globo? What shows are being watched, and so on. One interesting aspect of these use cases is that most of the use cases are designed for business people. They're not people with hard coding skills. They're not hardcore programmers. So designing a solution that's easy to maintain and easy to debug and see what's going on, that was one of the goals of this project. It's expected that these people will evolve the solution in the future create new data products as the business needs. So, as I said before, there was a legacy solution in place for the data processing. So one important question to ask is why do we need to migrate data pipeline? Why can't I just use the same data pipeline that was already in place? I think this slide tries to show the rationale behind this decision. I will not go into all the details. You can take a look closer. There's a lot of information. And we also have a slide talking a little bit more about the architecture. At the time, we had the feeling that it was possible to do something that was cheaper, faster, and more easy to maintain. But was still a quite vague idea at the time. So, covering two important topics. The first one is cost transparency. In the new GCP solution, we have no licensing cost. We just pay for the cost of the workload itself. We have much more control of where this cost is occurring, what's going on. Whether on the legacy solution was just a single cost for just processing and licensing, and we don't have really visibility what's going on. Feature-wise, we were able to implement new features that was not possible before, or at the very least, to improve these features. We're talking here about automatic scalability, easier reprocessing of failed jobs, processing only newly generated data, and so on. So, after the entire data pipeline was migrated, we measured all the results, and they were outstanding, much better than we have ever imagined. Without considering improvements in performance, in governance, or observability, we managed to achieve an annual cost reduction of 78%. That's a big number. This number alone justifies why the work was done and was a great return over investment for this project. We also reduced the processing time by 97%, data sets volume reduction by 34%, failure reduction by 92%. So why so good results? Is it magic? Is it what? I think that with improved transparency, more control, it became possible to be smarter about the utilization of resources and processing strategies and overall optimizations that was not possible before. I think that's one of the main reasons of the success of this project. In such a massive data set, that's a solution I would recommend for all of you going forward.
So, after we migrated the solution to GCP, we changed our data ingestion system to use all the GCP tools, and like JKA and Computer Engine for processing power, and GCS and BigQuery for persisting layer. So Global Play Big Data workloads are now using SQL pipelines in BigQuery, using Dataform with Composer to orchestrate all the process together. We also use Data Catalog, Data Studio, and Vertex AI to explore and generate insights. It's worth noting that we use this transfer service to move all the historical data from Hadoop files to cloud storage. And was very easy and helped us a lot in the process. Now, our resource allocation is not driven by the peak moments anymore. We auto-scale everything with the audience of the Global Play. So when the Global Play has a higher audience, we have allocate a lot more resources. When the audience decreases, we decrease the release of the resources. And this new solution was a great improvement for us in cost, speed, and it's a lot faster for us now adding new features in this pipeline, like a new segmentation or a new process in the pipeline. So that's what's helping us a lot to evolve all the metrics that we need for global play.